hopes in there, but I don't think it's a good.
All right, ladies.
Yeah.
Okay. So I did skip to chapter 6, 7, which is our exponential and log functions. I meant to get the new board up there, but I got bombarded in my prep this morning, so I didn't get a chance to. It'll be up there for Tuesday. It is way shorter than the last unit we just did. So there's only 2 lessons in chapter 7, right? And there's, jump ahead, I think, is there 6 lessons? If you guys look at the last lesson, 6 lessons or something like that in chapter 8. So it's not a huge unit, so we go through it quite quickly.
Chapter 8 is 7 lessons, but one of them is a 2-parter.
There you go. So again, not very long unit. All right, so chapter 7 is we are going to look at the exponential functions today. Do you think all the transformations that we just did in chapter 1 still apply?
Unfortunately.
Yes, okay. Transformations will be filtered through all the chapters, guys. The only chapter that you won't see something to do with transformations is chapter 11, okay? Chapter 11 deals with perms and coms, which has nothing to do with transformations. Every other single chapter will have some sort of speckle, right? Not a lot, but a little bit of transformation involved, just because we do graphs in all the chapters, okay, except chapter 11. So that's why we kind of don't get away from it. It's not obviously as compact as we just did, but it's still there, right? Because it can still help us with domain and range. It can still help us kind of picture what's happening with the graph and things like that. All right, so we have some exponential functions, okay? These functions happen a lot of times with growth and decay questions, so you'll see them in your chem classes, probably the most. You might see them in some physics graphs, you'll see, but definitely chemistry for sure. So did you guys read this little blurb here? I guess I didn't specifically tell you to read it, so maybe you didn't. All right, so when you're dealing with exponential graphs, okay, you're going to have a base function, okay? So what I mean by that is, like if I go y equals, even though I know you graphed one already, but if I say y equals, give me a number. Doesn't matter. 2? Sure. I heard 2 first. 2. And if I put an x on it, the base is a 2. That has nothing to do with the transformations. That is this exponential function has a base function of 2, which means, is it going to be increasing or decreasing? Increasing. So if I do this now to it, don't write any of this down. Oops. Let me write the k, not put a number there. Let's put a number there. So if I do that, do you guys see the transformations now? Okay. So the base function has nothing to do with the transformation. So this does not include anything to do with stretches, reflections, nothing. That's the base function. All of this stuff, guess what, is all the horizontal stuff. Okay, so this would still have a horizontal stretch by a factor of half, and it still would be horizontally translated 4 to the right. Okay, and guess what? This little guy right here and here still has to do with all the vertical stuff, the y. Right, so is the template kind of shifted around a tiny bit? Yeah, but it's still the same template. So all the stuff in the exponent is all the horizontal stuff, okay? All the stuff on the outside still is the vertical stuff. It's just we have this kind of extra value that sometimes our students are like, well, what does that do? It doesn't do anything. That just tells you what function you're comparing it to. So if I asked you guys to compare this, and I said the base function was this, that's going to be fun, right? Could you compare those two things? No, you can't. They're different base functions. You can't compare a y equals 3 to the x to a y equals 2 to the x graph. So the base function tells you, right, the original function. Okay. All right, so that's pretty much everything you need to know about this first lesson, okay, in a nutshell. But let's go through the characteristics. So, oh yeah, I'm up, I can. All right. So then one thing you will have to know is the base will also tell you if it's increasing or decreasing. Okay. So if the base, sorry, it flipped around there. So if the base, right, is greater than 1, it'll increase. Okay. If the base is between 0 and 1, it will be decreasing. Right. So let's do some characteristics. So with this, did you guys get a graph that looked like that? If you didn't put the horizontal asymptote in there, that's okay. Okay, but put it in there now. So with exponential graphs, okay, they will approach a horizontal asymptote. Okay, always. And how you're going to know where that horizontal asymptote is from the horizontal. Guess what does this? Or I shouldn't say horizontal. What's going to move something up and down? Vertical translation. Okay. So the vertical translation will move the horizontal asymptote. So if I gave you something like y equals 3 to the exponent of x minus 4, guess where the horizontal asymptote is? -4. Okay. So again, the vertical translation will tell you where the horizontal asymptote is. And the graph is going to approach it either on top of it or underneath it. We won't go through this horizontal asymptote with exponential functions because horizontal asymptotes, guys, believe it or not, you can go through it and approach it on the other side. Okay? You can get functions like that. You're not going to have it in this chapter because they're just exponential functions, but just realize, right, because I have lots of times students tell me, oh, an asymptote is a line you can approach but never touch. Okay, that's not true. Okay, it is a line that you approach, period. Okay, vertical asymptotes, you can add that extra piece to it. It is a vertical line that the graph approaches and never touches. And the reason why we can never touch a vertical asymptote, do you guys remember how vertical asymptotes happen? Right, it's restriction on the x that happens on the denominator, remember, of a fraction. So is there ever a case in the real number system that we can ever divide by 0? Can never happen. That's why we can never ever touch a vertical asymptote, because that number is never ever going to happen in this world. But horizontal asymptotes, there are different functions that we're not going to deal with at the 30-1 level, but there are functions that you might have a horizontal asymptote, and the graph comes down, goes through it, and approaches on the other side. Okay, that can happen. So I just don't want you coming out of my class going, asymptotes are something you can never touch. Okay, that's not true. Okay, there's lots of asymptotes. Yes, you will never touch them. You'll approach them. As you come down to them, you'll approach it, and then all of a sudden you'll turn, right, and approach it from the one side. But horizontal asymptotes, I'd rather you come out of my course, so I don't want you to go to university going, my teacher said. Okay, that's not what I said. Right? So with these horizontal asymptotes, we are not going to go through them because we can't, because of the actual math itself. So our horizontal asymptotes will either approach it, come down, approach onto it. Is there a scenario where we could approach on the other side? Even this one, guys. Well, could I apply to this so I approached it on the bottom half instead of the top half? Yeah, if I do a reflection in the x-axis, right? So if I apply a negative right on the front here, then this graph would just get reflected and I'd approach on the other side, okay? So we're going to approach, so a vertical, right, or a reflection in the x-axis will now, like I said, it'll flip the graph and then it'll still look the same, except everything's reflected, so it'll look like this. Do you guys agree? Right, but there isn't one in this one. So please, my expectation, if you are graphing these, that you put, it's an invisible line. I know that it's an invisible line, but I want you to show me the invisible line with a dotted line. So then I know that you know where that asymptote is, and you'll know where that asymptote is by looking at the function. You look for a vertical translation. Okay, that's where your asymptote will be. So what's the domain of this function? Oh goodness, sorry. Right, X is an element of all reals. I want you guys to make sure that anytime you're doing domain, okay, you understand the domain is that because of the function, not because of the graph. Because does the graph give it away that it's going forever left and forever right? But does the function give it away? Right? I need you guys to understand that if you look at that function, does it make sense that X has no restrictions? Because that's what domain is. You're asking yourself, is there any restrictions on X? Is there any restrictions on what you can put into that exponent? No, there isn't any. I can put any real number into that X value and not like have the calculator kick you out, because that's what you're kind of thinking. Restrictions means it's not part of the real number system. So what types of things does that happen? Square roots of negatives. Do you guys agree? Those are restrictions. So all our square root graphs, that's how we figured out our domain. Is we set our radicand greater than or equal to 0, and then we solve for X. That's how we got our domain of our radicals, okay? Same thing with all that rational stuff you guys did in 20. How did you guys get your domain? Was your restrictions on X, where your vertical asymptotes, or, you guys remember points of discontinuity? Right, all that stuff. That's how you figured out your domain for your rational functions, okay? So I'm always going back to pull stuff from your brain that should be there. And if it's not there, I'm putting it in, I guess, right now. All right, so are we all good? X is an element of all reals. There's no restrictions, okay? That for values that I can put in. So my range, okay, this range is a little bit harder to get from the function, right? But we still want to talk about it. Because from the graph, like looking at the graph, where is this graph approaching for a y value, 0. Is it going to touch it? No. So therefore, your range is, there we go. Our range is going to be everything where y is greater than 0. Do not put an equal to, because then you're touching the asymptote. Right. But please reason your way through that too, because if you picture putting any number into the function, okay, does it make sense I can't get negatives out? Right, because sometimes students are like, well, if I put a negative in for X, what kind of number you still get out? Right, you get a fraction, you still get a positive number. Right, because just remember our negative exponents. If I put a negative 2 in there, right, 2 to the negative 2 is actually what? 1 over 4. Right? If I put 0 in there, what do I get? 1. So there's no way that I can put any real number in for X and get a 0 out. That's why the asymptote's there, right? And then I start putting negatives in there. I still get positive numbers out, but really what kind of positive numbers? Really tiny ones, really small ones, right? Because if I put a negative 8 in there, right, it's going to be like 1 over 2, 4, 8, 16, 32, 64, or 128, I'm going to stop, right? So it's really, really tiny. So that's why this is getting really, really, really small, because the smaller negative number I put in there is it actually getting smaller and smaller and smaller, closer and closer to 0, okay? So always kind of reason your way through. Just don't go, oh, I can see the graph, it's that, but make sure that you understand why, okay? And x-intercept, what would you guys say? None. Can you ever get an x-intercept? Absolutely, right? Because if I vertically translate this 4 down, this whole graph, am I now getting an x-intercept? Yeah. So if there's no vertical translation, then no, because then if your asymptote is the x-axis, then you know that you're not going to get an x-intercept. Y-intercept, my y-intercept is, right, so exactly 0 and 1. So just a quick reminder on how to get a y-intercept. You let, even though do we have the point on the graph? We do. But let's remind ourselves that we're not always going to fill a table out and graph it. That if you just were asked for the y-intercept, you always let x equal 0, and that's what you're solving. And the reason why I'm going to keep reiterating this is on the 30-1 diploma, they'll put a bunch of variables in, right? So then you have to go through the process of still letting x equals 0 and simplify an expression, and your y-intercept is an expression and not an actual concrete number. Does that make sense what I'm saying? So they might do something like this. Right, so then if I asked you what's the x-intercept of that, or sorry, the y-intercept of that, you would tell me A. Does that make sense? Okay, so you have to always picture all the questions abstract, right? Because they're always going to try to build a question, so you can't just use your calculator. Okay. Not always, but probably at the 30-1 level, 75–80% of the time. All right, so here, 0, 1. And is this one increasing or decreasing? Increasing. And the equation of the horizontal asymptote is? Which one? Is it x equals 0 or y equals 0? Good, y equals 0, good. And if you forget, technically, because sometimes, I get it, got lots to remember, can you actually graph y equals 0 to confirm that that's the horizontal one? Right, because the x equal a number is the vertical one, and hopefully it kind of makes sense, because if I say x equals 5, that means that's the only x value it can be. So on the x-axis, you have to put a point at 5. And then, tick, 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 that's the only x value it can be. It has to be a vertical line. Right. Sometimes it'll talk about end behavior. Okay. So if it talks about end behavior, you can talk about it as increasing versus decreasing, but you can also talk about it using quadrants. So here, where are the ends? Like, what quadrants are they ending in? 1 and 2. So if they talk about end behaviors, you can talk about quadrants. So the end behaviors are quadrants 1 and 2. All right, so you guys go ahead, fill the table in now for the your turn. If you didn't dot your horizontal asymptote, please have that in there now. I'm going to switch up domain and range just to keep alternating. If you guys use the other notation, did you put a rounded bracket on the 0? Right, common mistake sometimes students do is they automatically put a square on it. And does it need to be rounded on the 0? Yes, because we can't include it. All right. So I briefly talked to you guys about this already. So is that feeling comfortable? Just the transformations when I start applying more values other than just the base function with an x. So again, everything on the outside is still all the vertical stuff. Okay, everything on the inside is just up in the exponent is all the horizontal stuff. Can't stress enough. All the outside stuff affects, if I'm talking domain and range, all the outside stuff affects the y, which is the range. All the inside stuff affects the x, which is the domain, if we're having to apply something for domain and range. Okay. All right, so for this one, right, so I still asked you guys to use your graphing calculator. Even if I would never make you guys apply all the transformations to all the points of the original when you have a graphing calculator. Just because it's easier just to plot it on your calculator, go to your table of values. But do I still expect you guys to look at this and tell me what's happening? Yes, that's all I care about. To me, I wouldn't waste time applying all the transformations to all the original points. That takes too long. Okay. Only time I would do that if it saves me time. right? In this situation, wouldn't save me time. So I would grab the calculator. Right, so did you guys get something that looked like that? So your original one, and then the one on the transformed one was really, really tiny underneath. So again, that's completely off the calculator. If you don't have that graph right now, do it later, right? You can type them both into the calculator. So let's go ahead and describe the transformations. All right, so we've done it enough now that I'm still doing shorthand now. So I'll still say long out of my mouth. So it's definitely a vertical stretch by a factor of, 1/2, right, about the x-axis. And there's definitely a reflection in the which? Perfect, x-axis. And horizontal stretch by what? 5. The y-axis. And a vertical translation. 5 down. Did I get all of it? Yes, got the reflection, got the 2 stretches, and got the translation. And notice how, guys, do we do anything with the 3? No, the 3 is just saying you have a base exponential function of 3. Okay. So what I would hope, right, when you guys graph these, now that you know this, okay, with this second one, where am I putting my dotted line with the second one? Kind of got moved, but the dotted line is at -5. Because did it have a vertical translation of 5 down? Yes. So I want you guys to be able to look at this. Okay, so I want you to be able to look at this and know where the vertical, not vertical, sorry. Yes, the vertical translation is, but where that affects your horizontal asymptote. So I'd expect you guys to be able to look at this and know that the horizontal asymptote is at where? -5. Is the graph above it or below it? Below it. So technically, do you know your range now? Yeah, your range is always going to be around that horizontal asymptote. It's either going to be above it or below it, okay? And your A value tells you whether it's going to be above or below. Because if you're using your calculator to tell you these things, you are not going to do well. Just because, is it hard to see sometimes on the calculator where it is? Yeah. Half the time your calculator looks like it stops the graph. And you have to know that the actual graph doesn't stop, right? Do you guys notice sometimes where, even with these, did it look like it stopped sometimes? I don't know if they do, but there's a lot of graphs, guys, that it won't actually graph all the way down. It'll stop. And the only thing I can remember or picture with some of these is, whoopsie, I've been changing my windows so much. I went exponent, but it didn't do exponent. There we go. Right? So with some calculators, not so much these ones, more with the root graphs, right? It'll look like it stops, but it doesn't actually stop. So you have to be very cautious. You have to understand the math behind what should be here. Because sometimes the calculator won't actually graph everything that's supposed to be there. Does that make sense? Because technically these calculators are only graphing functions, technically. So do you guys agree that not so much this one because it's horizontal, but if it ended up going the other way, which it will when we start logs, okay, the line will look like it's almost on top of each other, right? Because it's going like 0.000001 distance away from the next point. So a lot of times it looks like the graph stops. Okay? But your brain knows that it doesn't because you know the math behind what's happening. Right, so that wasn't a good example for these because you can see them, but all I'm saying, don't depend on your calculator to do the math for you. Understand the math behind it. All right, and graph that, graph that. Okay. So we graph that. that all we had to do with that one? Guess no characteristics. Okay, we're done. All right, so next one. So here, so I want you guys to be able to look at this without the graph, pretend the graph wasn't there. And we should be able to answer these questions without the graph, okay? So looking at y equals -2 bracket basis 3 all to the exponent of x minus 4 plus 1. So what's the domain? Is there any restrictions on x? No, because I can put anything into that exponent. There's no restrictions whatsoever. So my domain is -infinity to +infinity, or x is an element of all reals. Okay. Now the range, where's the asymptote? At 1. Do you guys agree? So the asymptote is at 1. Is this graph above 1 or below 1? Below 1, right? Because there's a reflection in the x-axis. So that means y has to be everything less than 1. And again, I can't stress that enough, just because what if they put like a 2/3, right? You're not going to see that on your calculator, right? So if you're trying to eyeball where it is on the calculator and not understand it from the equation, it just runs into too many errors. Right? So it's always going to be above or below the vertical translation every single time. That's where your range will be. So the equation of the horizontal asymptote, so the equation is y equals 1. It's always your k value, right? Y equals your k value, because that will be where the asymptote is. And x-intercept, so is this one going to be nice algebraically? Can we do it? Because if we do our x-intercepts, no, you guys don't know how to yet. After we do logs, because technically, if I asked you to do this paper pencil, is this how you would start the question? If I asked you to find your x-intercept algebraically, would be your first step? You guys all agree that would be your first step? So you could do 2 more steps. Do you guys agree algebraically? You could move the 1, and you could divide by the, so you'd move the 1, get a -1. You'd divide by the -2, you would be now at half. Okay? But do you guys see a problem that we're running into? You don't have the algebra skills yet to get the x out of the exponent. That's chapter 8. So by chapter 8, you can do this algebraically. Okay? But this chapter, guess what we have to use so far? You have to use your calculator, right? Because you don't know how to use logs yet to be able to solve that algebraically. So we grab our calculator. So I promise you, chapter 8, you can actually do this whole thing without the calculator. But right now we can't. So then you would go, I just do left-hand side, right-hand side. So one side is 0, the other side is -2 times 3 to the exponent of x minus 4 plus 1. Did I type that in right? Yes. So graph. And then we're going to do, I do it that way. You guys could have just typed it in and did left bound, right bound, but I don't do it that way. It's way too slow. So calculate, intersection, enter, enter, enter. So are we good with 3.4? So 3.4 would be nearest 10th. And the other reason why I use intersection method, guys, does it continually remind you guys that how do you find an x-intercept? You let y equals 0, right? That is the algebra on how you would do it otherwise. Y-intercept, we let x equals 0. So again, yes, we can do it on the calculator. I will remind you how to do it on the calculator, but technically, so we have 0 minus 4 plus 1. So that's going to be minus 2 times 3 to the exponent of -4 plus 1. Make sure that I typed that in right. So nearest hundredth, so 0.98. if you use the graph to do it, I just have to get rid of the 0 out of there. But if you want to put an x value in, doesn't matter what x value, there's 2 ways to do this. I just hit trace, because if you hit trace, you automatically get numbers on the bottom. Normally it'll actually give you the y-intercept right off the bat, but if it doesn't, you just type in a 0 and hit enter. Okay. The other way that Miss Miller might have showed you guys is you can actually go into the calculate screen, you go second trace and hit value. That's automatically makes an x happen as well. And then you can put whatever value you want in for x. And we know that with a y-intercept, x is specifically 0. So you have to put a 0 in there. So right now we are kind of focusing on technology, but please always know how to do it without using technology. Right. So that is that. Okay, so that is everything I need to let you guys in on to be able to do all the transformation stuff, all the x-intercept, y-intercept characteristics of the function. So with that, you can try the 3 diploma questions and then go from your textbook questions. So pretty